Superalloys constitute another class of high temperature alloys which are very useful at temperatures up to zero point 0.8 times the melting point. What are the underlying principles on which the superalloys are based? So one of the concepts involved in the formation of superalloys is precipitation hardening, and as we know that in the precipitation hardening the important source of strength is the fine distribution of precipitate which block the movement of dislocations. But with the increase in temperature, the precipitates start coarsening, that is increasing in size, which reduces the strength of the material. In this particular case, superalloys, the one of the driving, if we see that to avoid the coarsening of precipitates, what is the basic mechanism which leads to increase in the precipitate size during increasing temperature is the reduction in the interfacial free energy. So precipitate will definitely like to reduce its energy of the interface which it forms with the matrix, and that with the increase in size that reduces because the area which is in contact with the matrix reduces. So one of the ways in which this can be reduced without increasing the size is forming a coherent interface. So the nature of the interface between the matrix and the precipitate actually governs the interface energy along with the size of precipitate. So if the precipitate is coherent, that is a one-to-one match between the lattice parameter of the precipitate and the matrix, then the interface energy is very less. So this concept is utilized in the superalloys, that is there in the nickel based superalloys. The alloying elements such as aluminium and titanium are added, which leads to the formation of intermetallic compound as a precipitate, that is Ni3Al-Ti, and this has a very small interface energy with the nickel matrix, that is of the order of 0.005 joules per meter square, and this gives them unusually high strength even at very high temperatures. So that is why they are also called superalloys, and this is a very important mechanism which is utilized in further development of alloys at high temperature.